it in a burst, yeah, right at FuSha Works.
The discovery of Linagliptin for treatment of type 2 diabetes mellitus. Linagliptin is a dipeptidyl peptidase 4 DPP4 inhibitor and works by reducing the rate of inactivation and degradation of glucagon-like peptide, GLP-1, as well as glucose-dependent insulin-tropic peptide, GIP. First introduced in 2011, Linagliptin is an oral anti-hyperglycemic drug taken in the treatment of type 2 diabetes mellitus, abbreviated T2DM, to give patients a better control over their glycemic levels. Linagliptin is a highly selective molecule that targets and removes a peptide from the N-terminal of GLP-1 and GIP respectively. In doing so, Linagliptin prolongs the lifespan and thus the effect of these oligopeptides in maintaining glycemic control after a meal. The discovery of Linagliptin started with a high-throughput screening, or HTS, of over 500,000 molecules. Of the molecules that were screened, compound 2 displayed great promise due to its xanthine scaffold, and was used as an initial point for designing an effective DPP4 inhibitor molecule. The structure-activity relationship, or SAR, of compound 2 revolved around 4 residues, which are N1, N3, N7, and C8, and how their substituents linked to the xanthine core affected the inhibitory profile of the molecule. The residue on C8 went through multiple variations, and it was discovered that 2-amino-ethylamines, particularly 3-amino-piperidide, displayed an increase in the molecule's inhibitory activity. This shows how crucial the contribution of a basic amino group is. At N7, either but2-enal or 3,3-dimethyl-prop2-enal showed good DPP4 inhibition activity. For the N1 residues, attachment of phenylacyl or fused bicyclic aryl or heteroaryl methyl functional groups gave rise to molecules with very high potency. However, there was a high degree of interaction with the muscarinic receptor 1, M1, and the human ether agogo-related gene, HERG, channel for all variations of N1 with dimethyl allele on N7. Thus, to reduce the unwanted side effects, but2-enal was attached on N7 instead. For the residue on N3, varying R groups were attached to study its impact, and a new synthesis route was designed with compound 7 as the starting molecule. From the Scaffold Study, it was concluded that a prerequisite for high DPP4 potency would be an optimal heteroaryl methyl and carbonyl group alignment, where a coplanar relationship exists between the imidazole ring and the amide group, and with the carbonyl oxygen placed next to the butanol group. From this selection process, 4 compounds, including Linagliptin, were identified to meet all the criteria of an ideal DPP4 inhibitor molecule. Ultimately, Linagliptin emerged as the superior molecule, with it displaying high potency in all animal models tested, having a high selectivity towards other receptors and enzymes, and with a favorable pharmacokinetic profile. With that, this brings us to the end of the presentation. Here, you can find a compiled list of references that was used in the making of this video presentation. Thanks for watching.